Hello everyone, welcome to this session. In this session, we are going to discuss the important concepts. We are going to list out the important concepts and few important questions which can be expected in the examination. So as you know very well, that is, we are going to list out the concept from the theory of machine subject and vibrations. We will start with the chapter 1, that is mechanisms. In this chapter, guys, you can expect a question from mobility analysis of planar mechanism, that is computation of degree of freedom. After it, guys, the most important concept, that is Grashoff's law. Okay. Grashoff's law. So using this law, you will be able to find the inversions of various mechanisms, or you will be able to predict that whether the mechanism is suitable for transmitting the relative motion continuously or not. So again, under that, after the Grashoff's law, another most important one is the inversions of mechanism. So in this inversion, guys, we have 4-bar mechanism. 4-bar mechanism. So I am abbreviating this as F4FBM, 4-bar mechanism. Next is slider crank mechanism. Slider crank mechanism. And next is double slider crank mechanism. So you can expect an objective type question from these three mechanisms only, okay, based on the inversions. And the another most important topic, that is quick return motion, quick return mechanism, I should say. Quick return mechanism, here we have crank and slotted lever mechanism and Whitworth mechanism. Crank slotted lever mechanism and Whitworth mechanism. So from here you can expect questions. Okay, but numerical questions you can expect only from the mobility analysis. Okay, so another part of the mechanism, guys, is velocity and acceleration. Velocity and acceleration analysis of mechanism. So here, don't expect a complex question or a complex mechanism and then they are asking you to do the velocity or acceleration analysis. The questions will be given in a very simple way, or it may take only 30 to 40 seconds for you to solve. The question will be framed like that. And from here, guys, the most important concept which is being repeated frequently in the various state examination is the Coriolis component of acceleration. You can find this to be repeated many number of times. Okay. And sometimes they might also ask us about the standard results relating to slider crank mechanism. Okay, standard results, that is expression of velocity of piston, expression of acceleration of the piston, or expression for angular velocity of connecting rod, like that. Okay, standard results of velocity and acceleration analysis of slider crank mechanism. So these are the topics, guys, from where you can expect the questions. All right. And the next one under mechanisms, we have dynamic analysis. Dynamic analysis of slider crank mechanism you can expect here. So basically, if you are able to draw the, if you are able to remember the crank slider mechanism, and on that mechanism, if you are able to identify the forces acting on piston, connecting rod and crank, and then if you are able to relate all those forces mathematically, then this chapter can be completed, or this topic can be completed within, I mean, half an hour it can take. Okay, so these are all the concepts from the mechanisms chapter. Next, guys, we have is vibrations. From the vibrations chapter, guys, they might ask us to calculate the natural frequency for any given system. So here you should be in a position to draw the free body diagram. Okay, after that only you can do the, you can calculate the expression for natural frequency. And the next most important one is, they might ask you the questions relating to critical damping. Critical damping or damping factor also. Okay, damping factor. And similarly, when you are calculating natural frequency, they might also ask you to calculate damped frequency, or either frequency or time period they might ask. Okay, and from another very important topic where the questions can be expected is the dynamic magnification factor. Dynamic magnification factor. This is basically, here you will be doing the study on a graph, okay, at various values of ratio of frequencies, and for different values of zeta, you are going to predict where exactly the resonance will occur and how their behavior is going to be, okay, for various values of the frequencies. This is from where you can expect a reasoning question, guys, or a theoretical question. And after that, another very important concept is transmissibility ratio. Transmissibility isolation. Okay, there is a graph relating to transmissibility ratio and ratio of frequencies. So in that, for different values of ratio of frequencies and for different values of zeta, you are going to predict what would be the suitable frequency, where exactly the isolation occurs, and where exactly the transmissibility will be more or it will be dangerous for any particular machine. Okay, so that you are going to predict here. All right, so these are the list of concepts in the vibrations chapter. And the next chapter we have is gears. So in gears chapter, guys, you can expect a question from the nomenclature. Gear nomenclature. Okay, that is relevant to the geometry of gears, like module, circular pitch will be there, arc of contact, pressure angle, all these parameters, or they might give you a standard definition. Definition will be given to you, and then you are required to choose a proper keyword to match that definition. Okay, so that there you can expect a question. And the next one where you can expect a question is from, I should say, interference phenomena. Very important one, interference phenomena. So in the interference, when exactly the interference will occur, and along with that, methods to avoid interference, methods to avoid interference. So from here you can expect question. And after it, guys, we have velocity analysis. Velocity analysis. That is for simple gear train, reverted gear train, epicyclic, and the what we call compound gear train. So velocity analysis, from here also you can expect the question. So these three are the main chapters. I mean, you can expect more number of questions from these three chapters, and these are going to consume a lot of time, okay, where compared to other 5 chapters. All right. So next chapter, guys, here would be flywheels. Flywheels, you will be getting a straightforward question. Either they may ask about the fluctuation in energy, or they may ask what is the kinetic energy stored, okay, or they may ask about some that is angular acceleration of the flywheel, they may ask. Okay, so they might ask, I think, fluctuation in energy, okay, or kinetic energy stored, or else acceleration of flywheel, So these are the concepts from where you can expect the questions. And questions from this chapter are formula based questions, or single formula will be given, and in that you have to substitute the values, and that's it. No more critical thinking, I should say. Okay. And next chapter we have is CAM and followers, CAMs. So from this CAMs, you can expect the question on nomenclature, that is terms which are describing the CAM and follower mechanism, or CAM geometry. You can expect a question on that. And along with this, you can, straightforward questions are there from the velocity and acceleration analysis, where you will be dealing with the standard results which are obtained from uniform velocity, uniform acceleration, simple harmonic motion, and cycloidal motion. So all these four kinds of motions are there, and for these four kinds of motions there are standard results available, and then for the standard results they might ask either the expressions or simple problems. Okay, so velocity and acceleration analysis. So under this will be carried out only for four types of motion. One is for uniform velocity, one is for uniform acceleration, and followed by simple harmonic motion and cycloidal motion. So these are the concept, guys. So far I think we have completed 5 chapters, another 3 to go. So next chapter will be governors. From the governors chapter, you can expect a question, straightforward question from the Watt governor. And sometimes, I'm not predicting, so maybe they might ask from the Porter governor, but Pro-L governor need not to study, only remember the standard results, because Pro-L governor is more of elaborative type, so you can simply leave that. And otherwise, another very important one which we have is Hartnell governor. So they might ask about the stiffness expression in the Hartnell governor. Okay, so whereas Watt and Porter governor, you have a standard relationship between the speeds of Watt and Porter governor. You can remember that also, because that was also asked in many times in the various state examinations. And apart from these 3 topics, guys, the most important one we have is controlling, guys. Controlling of governor. So here we are able to predict whether the given governor is stable or unstable or isochronous. So here, this is the most important one from this chapter. You can expect a question on this. Okay. So there are various parameters relating to controlling also. Sensitivity is there, hunting is one of them. Okay. And range of speed is there. All these are parameters relating to controlling of governor. So you can expect a question out of here. And the next chapter we have is gyroscope. Gyroscope, guys, here you can expect a straightforward question from the aeroplane, that is effect of gyroscope on the aeroplane, okay, or else naval ships. Naval ships, you can expect a question. So here only single formula is there, that is C is equal to gyroscopic couple is equal to I into, that is mass moment of inertia, into velocity of spin, into velocity of precision. We are going to make use of this single formula only, but you should have the thorough understanding of right hand screw rule. Only then you will be able to solve the problems or the case studies relating to aeroplane or naval ships. And otherwise, you can expect what you call a simple question on the four-wheel drive. It was asked one time, so I'll be definitely discussing this four-wheel drive. Especially here, the student may face the problem to draw the direction of forces. So we'll just do a simple case only, but we'll not be doing the numerical solving. We'll just identify what are the forces and how they are going to act. Only that study we will be doing for the four-wheel drive. Okay. So gyroscope is another chapter. After it, guys, we have is balancing of masses. Balancing of masses. So this chapter, guys, they have given very least preference. Actually, very less number of times the questions were asked. Balancing of masses. So here we have two types of balancing. One is the balancing of rotating masses, rotating mass, and reciprocating mass. Okay. In rotating mass, again, you will be studying about the static balancing and dynamic balancing. So that is static balancing will be there and dynamic balancing. Static and dynamic balancing will be there. So in static balancing, you will try to predict that there will be no unbalanced forces acting on the system. Whereas in case of dynamic balancing, you will be able to calculate whether there is unbalanced force, unbalanced couple exerted on the given system or not. That will be done in the dynamic balancing. Similarly, reciprocating masses is there, but very less number of questions were asked from this chapter. So, I mean, by suggestion, if you ask that how to prepare, so I would go in this sequence that I'll start first with the mechanisms. Okay, then I'll go with the vibrations chapter, and then would be the gears, gear and gear trains. Okay, gears and gear trains, actually it is. Gear train is also included. So once these three chapters are completed, after it you can switch for the remaining 5 chapters, that is flywheel, cams, governor, gyroscope, and balancing of masses. So these are going to take very less time. Okay, so now let us start the discussion take the discussion forward by taking the questions from the previous exams. Okay, so here is the first question, guys. The degree of freedom for the following mechanism. So here it is a simple 4-bar mechanism given to you and very well known to all of you also, and you can calculate degree of freedom very easily. So here number of links, you know very well, it is 1, 2, 3 and 4. Number of links is 4, and this will be joint number 1, and this will be joint number 2, and this will be joint number 3, and this will be joint number 4. So number of links is equal to 4, number of joints is equal to 4. Degree of freedom will be equal to 3n minus 1 minus 2j minus h. As of now, guys, in this mechanism, there is no higher pair included. Okay, so which is equal to 0. So this will be 3 into 4 minus 1 minus 2 into 4, which is equal to 9 minus 8, which is equal to 1. So this 4-bar mechanism, guys, we also refer this as constrained mechanism or kinematic mechanism. We call this as kinematic mechanism or constrained mechanism. Okay. Now, guys, here one more point I would like to add here. If a mechanism is consisting of all the revolute joints, here it is consisting of all the revolute joints. So let me make an observation here. We'll add few observations. So if the mechanism is consisting of all revolute joints, number of links required to obtain kinematic mechanism is equal to 4. Now guys, another point, what if the mechanism is consisting of all prismatic joints? Okay, all prismatic joints. Okay, this case study is actually available in Amitabh Ghosh and Malik. So when you are constructing a mechanism by using all the prismatic joints, then in that case, number of links required will be equal to 3. Remember this. Number of links required to obtain kinematic mechanism. This is equal to 3, guys. This is equal to 3. You can refer Amitabh Ghosh and Malik. There you can understand how this 3 is obtained. Actually, the arrangement will be something like this. A L-shaped link will be there. In that L-shaped link, we are creating a prismatic hole, and in that we are inserting 2 links. Okay, we are inserting 2 links. So by inserting these 2 links, you are able to get single input and single output. So that is what it makes. I mean, here you are, by using the lower pairs, the minimum number of links is 4 actually, but specifically if you are using 4 revolute joints, the number of link is 4. But if you are using prismatic joint, then it is 3. Okay. Similarly, in case if the mechanism is consisting of lower pair, that is revolute joint and higher pair, if it is there, then number of links is equal to 3. This you will be seeing in the gear and pinion arrangement. Similarly, this you will be able to see in the cam and follower also. Cam and knife. In case of knife edge follower, between the knife edge follower and the cam, there is a higher pair formed. Between the follower and the frame, there will be a prismatic pair formed. Between the cam and frame, a revolute joint is formed. So when you are making use of a lower pair and one higher pair is included, then when the number of links required to obtain kinematic mechanism will be equal to 3. So please remember all these 3 statements, guys. So you might expect this in the objective type also. Okay, moving to the next question. So if D is the pitch circle diameter and T is the number of teeth, then the module of spur gear is defined as, module, guys, you know it very well, that is module is equal to diameter by number of teeth. Okay, so that is diameter by number of teeth. Option A is the answer here. Okay, and here it was option A was the answer. Sorry, I did not write here. So option A was the answer in the previous case. So for module we write this way, and pi d by t, guys, we refer this as circular pitch. Okay, circular pitch, and t by d we write it as also diametrical pitch. Okay, so this is generally used in the FPS system, that is foot-pound system. So this we will be using number of teeth per inch. We will be using this to designate number of teeth per inch. And option D says that is D into T, which is not a correct expression, guys. So as per the question, option A is the answer. Okay. Moving to the next one, the smallest circle in the cam profile. Now guys, while doing the construction for the cam profile, let us say this is the center of rotation, and let us say this is the roller follower. And another case I will take with knife edge follower. So now guys, here the smallest circle which is tangential to this cam profile, smallest circle which is tangential to the cam profile, it is tangential to the cam profile. This we call it as base circle. Here also it will be tangential to the cam profile. It will be tangential. Please don't mind if the circle is not touching or if this is not looking like a circle. Now guys, another thing here it is, this point or the point of contact between the follower and the cam, it is going to move along the cam. Okay, it is going to move along the cam. So this we call it as trace point. Locus of trace point is called as cam profile. Okay, locus of trace point we call it as cam profile. Sorry, locus of trace point we call it as actually pitch curve, guys. Let me just correct, it is actually referred as pitch curve. It is pitch curve. Okay. Whereas in case of roller follower, this will be the trace point. So the trace point is going to move along the cam profile. So once it is moved along the cam profile, okay, this we call it as pitch curve. All right. Now here guys, you can say the cam profile and pitch curve are coincident, but here the cam profile and the pitch curve are distinct. Okay, they are different. Similarly, here you can say base circle is tangential to the pitch curve as well as to the cam profile. Yes, correct. Here base circle is tangential to only cam profile, but whereas for the pitch circle it is not at all touching. So now guys, there will be another circle which is going to be tangential to the pitch curve, and that circle we will be calling as prime circle. That circle we will be calling as prime circle. Here, in case of knife edge follower, base circle and prime circle are coincident. Base circle and prime circle are coincident. Please remember this. Okay. So the smallest circle in the cam profile is the base circle. Okay. Generally it is the base circle, not prime circle. All right. So here all the terms has been explained. I guess prime circle is the circle which is tangential to the pitch curve, and pitch circle. Okay. Pitch circle is there. Pitch circle has no relation with the pitch curve. Understand that. This pitch circle has no relation with this pitch curve. Please remember that. So I'll take this pitch circle separately. Now guys, for this pitch circle, we need to recall pressure angle in the cam. Pressure angle. We need to recall the pressure angle. Pressure angle is the angle between the line of stroke of the follower, line of stroke of the follower and the common normal. And the common normal. This we call it as pressure angle, guys. The point where pressure angle is maximum, that we call it as pitch point. That we call it as pitch point. And locus of that pitch point is called as pitch circle. So pitch circle has something to do with the pressure angle. Understand that. Okay? Pitch circle has pitch circle is nowhere related to pitch curve. Please remember this. Okay? So commonly misconception among the students. So please remember that it has no relation with the pitch curve. All right. So this is about the nomenclature of the cam. Let us go to the next question. In case of coaxial shafting, which type of gear train is used? So this coaxial shafting, guys, a very common application of this coaxial shafting we will be finding in the clocks. Okay. So in the clocks you can see the speed of seconds arm and the minutes arm and the hours arm, it will be varying. So and then for that we will be using the reverted gear train, guys. For that we will be using the reverted gear train. So the arrangement will be something like this. First will be the pinion, the smaller gear. After that the larger gear will be there. If you are interested in obtaining the reduction, then we will go for the larger gear, and larger gear will be compounded with another smaller gear, okay. And similarly this smaller gear will be meshing with a wheel of larger size. So here this becomes the input shaft, this becomes the input shaft, and this becomes the output shaft. Okay. So here both the input and output shafts are coaxial, but they will be, it is not, both the input and output shafts will be coaxial only. There is some break in between them. Okay. So that happens in only reverted gear train. Okay. Whereas in case of simple gear train, all the gears will be lying in the single plane. Okay. But their axis will be parallel. That is, all the gear axis will be lying in the single plane. Okay. Similarly, in case of compound gear train, there will be gears will be lying behind in the parallel planes. Gears will be there in the parallel planes. So here, guys, without compound gear, it is not possible to have a reverted gear train. Understand that. So compound gear is needed, only then we can go for reverted gear train. Okay. So as per the question, option A will be the answer. Next one, for the start of the engagement to the end of the engagement, the pressure angle for the gear having involute profile. So for involute profile, from the starting of the engagement to the end of the engagement, the pressure angle remains constant, guys. It is not going to vary. Okay. But in case of cycloidal teeth, okay, the pressure angle will be maximum at beginning. Pressure angle will be maximum at beginning, 0 at the pitch point, 0 at pitch point, and once again at the end of engagement it becomes maximum. At end of engagement. So pressure angle is varying in case of cycloidal teeth, whereas for involute teeth it remains constant. It remains constant. So option D will be the answer, and do remember the points relating to the cycloidal gear or cycloidal teeth, I should say. Okay, moving to the next question. If the speed of the governor fluctuates continuously above and below the mean speed. So this phenomena which we refer this as hunting phenomena. Okay, so this will be happening when the governor is sensitive for a small change in speed or for small change in load. If it is sensing and then for that it is causing this fluctuation, then the governor is said to be hunting. Okay, governor is said to be hunting. So this, in case of stable governor, this fluctuation above or below mean speed will be very, very less. That is when we refer the governor to be as stable. Okay. Next is governor is said to be insensitive. Insensitive means when there is a load, when the load is increased or we are required to increase the fuel supply based on the change in load. So if that is not being sensed by the governor due to presence of friction at the sleeve, okay, governor is not able to respond, then the governor is said to be insensitive. For insensitive, the friction force will be responsible. Friction between sleeve and spindle. If that friction force is more, then over a small range of speed, the friction force is not overcome. We require to change or we require to increase the speed by more amount so that the friction force is overcome, and then there will be some sleeve displacement. So insensitiveness is something relevant, or insensitiveness is due to the presence of friction at the sleeve. Next is governor is said to be isochronous. Isochronous is actually a theoretical condition for the governor, guys. Okay, so for isochronous governor, which means that at here at any equilibrium radius, the speed of the governor remains the same. That is not possible. For every unique radius of rotation of fly balls, there has to be a new value of speed. Okay, but in case of isochronous governor, for every new radius of fly balls, the value of speed does not change. That governor we call as isochronous governor. Okay, but as per the question, guys, that is governor is said to be hunting. So option D will be the answer. Okay, next question. The engine shaft of an aircraft engine rotates in counterclockwise direction when viewed from the nose. So aircraft is given. So from the nose end, the observer is present. Okay, and it is rotating in the counterclockwise. So if I am curling the fingers of my right hand in the counterclockwise, the thumb is pointing towards the observer. This becomes omega of, this is going to define the spin velocity. This vector will be defining the spin velocity. Aircraft is taking the left turn. Aircraft is turning towards left side. So left side is decided by the pilot, not by the observer. Understand that. Okay. So it is turning to the left hand side, which means that it is coming out of the screen towards this. So the vector, this vector will cause the left turn in the aeroplane. All right. So here we are required to place this vector, or this is going to define omega spin. This is going to define omega spin. The trick is very simple. Rotate omega spin. Sorry, this is omega precision, guys. I am sorry. This is omega precision. Omega precision. So the trick is very simple. Rotate omega spin in the direction of omega precision by 90 degrees. Okay. So let me write here. Rotate omega spin in direction of omega precision by 90 degrees. Okay, we get the direction of active gyroscope. So if we rotate this in the direction of omega precession, you will be seeing the vector in the new orientation along the z-axis. This will be active gyroscope, active gyroscope. And opposite to this will be reactive gyroscope. Opposite to this will be reactive gyroscope. So place the thumb in the direction of reactive gyroscope. You will see the fingers are curling in this orientation. So the fingers will be curling in this fashion. Now pick this vector and place it on the aeroplane. Pick this vector and place it on the aeroplane. That's it. You will see here the tail is being dipped and the nose is raised. So which option is saying that? Rising the nose and lowering of the tail. Option D will be the answer. And here option B and C you can read here, that is lowering of nose and tail. This is not at all correct. Raising of both nose and tail, this is also not at all correct. Either A or D could be the answer, guys. Okay. So by elimination also you can do, but here you should be having the thorough understanding of right hand screw rule. Okay. And remember this key point also. This is key point to solve any problem. Okay. Let us go to the next question. Epicyclic gear train has dash degrees of freedom. So here epicyclic gear train, guys, it is comprising of sun gear, planet gear. Along with this you will be having arm also. Okay, along with this you will be having arm also. So if you have studied in the tabular method, that is in the tabular method, first line we will be writing the input is given to the sun gear, whereas arm is fixed. Second line we will be writing that is input is given to sun gear by X revolutions. But very next in the third line we are writing that the arm is rotated by plus Y revolutions, which means that we are giving two input to this epicyclic gear train. Two inputs. Okay. So when we are having two inputs and a single output, what is that single output? Planet is the single output. Okay. So in that case, degree of freedom will be equal to 2. So degree of freedom is going to help you predict for running that particular mechanism by giving a single input, how many number of outputs are possible. If the degree of freedom is 1, then it is a single input, single output kind of a mechanism. But if degree of freedom is 2 or 3, then which means that if I am giving a single input to the mechanism, there will be possible 2 outputs or 3 outputs. Or else, for obtaining only single output, how many number of inputs I am required to give? That will be predicted by the degree of freedom. So straightforward answer, that is for epicyclic gear train, degree of freedom will be equal to 2. But whereas in case of simple gear train or reverted gear train or compound gear train, degree of freedom will be 1 only. Until and unless if you are adding the arm, then it might be different. It will be different. Okay. So if it is epicyclic reverted gear train, degree of freedom will be 2. If it is a compound or epicyclic compound gear train, then degree of freedom will be 2. Okay. Remember this point. Next one, yeah. Next one, governor effort is the force applied for 1% change in speed, 10%, 50%, 100%. So this question was given with these kind of options in the examination. Need not to worry, guys. Whatever you mark, all the answers are correct. But technically speaking, governor effort is the force applied for percentage change in speed. Percentage change in speed. That percentage could have any value. Okay. For a given percentage change in speed, the average force exerted on the sleeve is called as effort of the governor. Okay. Similarly, effort will be there. Another parameter what we have is power also. Power we write it as effort into sleeve displacement. Okay. This is work done on the sleeve for percentage change in the speed. Okay, so here whatever the option you choose, anyways it is going to be correct only, guys. So the keyword, the correct keyword here, they should have been given as for a given percentage change in speed. Okay, now let us move to the next question. Yeah, so a flywheel of a steam engine has a radius of gyration of 1 meter and mass of 2500 kgs. So radius of gyration is given as k equal to 1 meters. Okay, and mass of the flywheel is 2500 kgs. Now guys, the starting torque is equal to 2500 Newton meters it is. The kinetic energy of the flywheel after 10 seconds. Standard relations you are supposed to use here. Torque is equal to I alpha. Torque is given as 2500. I is equal to, that is mk square. I is equal to mk square into alpha. So here this will be 2500 into 2000 is equal to 2500 into 1 square into alpha. So alpha here will be equal to 1 radian per second square. 1 radian per second square. So after 10 seconds, what will be the speed? So omega is equal to alpha into t it will be. So after 10 seconds, the speed will be 10 radians per second. This will be the speed. Now you are required to calculate the kinetic energy, that is instantaneous energy in the flywheel after 10 seconds. So standard relation is there, kinetic energy we write it as k is equal to 1 by 2 times of I omega square. So 1 by 2 into I is 2500 into 1 square, that is 2500 only, into 1 square, that is 10 square. That is 10 square. So this can be written as, this will be 1250 into 100 it is, guys. Or this we can write it as 125 kilonewton meter will be the kinetic energy stored in the flywheel. Okay. So option D will be the answer. Option D will be the answer. Okay. Now let us move to the next question. In case of slider crank mechanism, if the mass of the slider is 1 kg, mass of the piston they have given, this is equal to 1 kg. Crank radius is 10 centimeters, that is crank radius R is equal to 10 centimeters, or which is equal to 0.1 meters. Length of the connecting rod is 40 centimeters. So L is equal to 40 centimeters, or which is equal to 0.4 meters. Then the inertia force at 0 crank angle, theta is equal to 0. What is the inertia force? This is also a standard result, guys. F inertia we write it as mr omega square into cos theta plus cos 2 theta divided by n. N is the ratio of L by R, that is equal to 10 by 40, which is equal to 4. So the speed here, I think the speed data is missed here, guys. The data of speed is missed here. So mass is given. Mass is equal to 1 kg, radius is 0.1, omega is anyways missing, guys, so let me just complete it this way only. So cos theta cos, this is 0 plus cos 2 into 0, that is cos 0, divided by 4 it will be, divided by 4. So this will be the inertia force exerted on the piston when the crank angle is 0 degrees. Okay. So this will be the expression, guys. Do remember, It is also a standard one only. Okay. Now moving to the next one. The spur gear has a module of 3.5 mm and length of path of contact is equal to 11 root 3 mm. It is 11 root 3 mm it is. Pressure angle is 30 degrees. Okay. So module is equal to 3.5 mm and length of path of contact is equal to 11 root 3. Pressure angle, that is phi, is equal to 30 degrees. Contact ratio they are asking. Contact ratio, that is equal to arc of contact by circular pitch. Arc of contact by circular pitch it is, guys, not circular path. Okay. So arc of contact, we can write contact ratio as that is length of path of contact divided by pi times of module into cos phi it is. This is 11 root 3 divided by 11 root 3 this is 11 root 3 divided by pi, module is 3.5 into cos 30, it is cos 30. So upon solving this, we'll be getting this as approximately equal to 2, guys. This will be 2, it will be. Okay. 2 will be the contact ratio. Option C will be the answer. Okay. Pi into 3.5 is approximately 11 only. And root 3 by 2 here, and root 3 will be cancelled and 2 will go on the top. Okay. So option C will be the answer. Alright. Next one. In a simple gear train, first gear has 40 number of teeth, second gear has 20 number of teeth, and the third gear and the last gear has 80 number of teeth. Then the train value is dash. Train value, we write it as product of number of teeth on driver divided by product of number of teeth on driven. Okay. So if 1 is the driver, then 2 becomes driven. Similarly, 2 becomes the driver, 3 becomes the driven. This continues, guys. So this will be Zn minus 1 by Zn for n number of gears. Okay. So anyways, here, guys, we can notice that 2 and 2 will be cancelled. Similarly, 3 and 3 will be cancelled. Zn minus 1 and Z1 by Zn will be left over. Z1 by Zn will be left over. Okay. Already it is mentioned it is a simple gear train. In case of simple gear train, guys, we will be directly taking the ratio of the first gear, that is the driver, and the driven. Directly if you take the ratio, that is enough. But whereas in compound gear train, you will be seeing some of the terms might not get cancelled. Okay. That happens in the compound gear train. But in simple gear train, this cancellation happens very easily. So this is number of teeth on first gear is 40 and the number of teeth on the last gear is 80. Okay, that is 40 by 80, which is equal to 0.5, which is equal to 0.5. Option A will be the answer. Okay, option A will be the answer. All right, next, let us move to the next question. Yeah, this is a very, very important one, and especially student might be having a little bit of struggle while deciding the direction of forces. Okay, so if four-wheel automobile is taking a turn towards the left, consider W to be the weight of the vehicle and P by 2 to be the magnitude of reaction due to gyroscope and Q by 2 to be the magnitude of reaction due to centrifugal effect on the inner wheels or outer wheels. The total vertical reaction at each inner wheel is dash. Okay, so now guys, let us take this, try to understand from the top view first of all. So this four-wheel drive is taking the left turn. Left turn means it is going to turn like this. All right. Reaction due to weight, definitely it is W by 4 on all the wheels. W by 4, W by 4. No doubt here for writing this W by 4. Okay. You don't have to apply any concept or logic. Already you have studied this in engineering mechanics. So W by 4 will be there. All right. Now guys, let us try to understand from this view first of all. Okay. So the car is moving forward. You are the observer looking normal to the board. So here this car is going to take left turn. It is going to take the left turn. So now guys, when the car is moving forward to the right side, these wheels will be rotating in the clockwise sense. These wheels will be rotating in the clockwise sense. When the wheels are rotating in the clockwise sense, if I am curling my fingers in the clockwise sense, you can see thumb is directing towards the board. Thumb is directing towards the board. This will be velocity of spin. Velocity of spin it will be. Okay, that is in the negative z-axis. Negative z-axis. Now the car is going to take left turn. It is going to take left turn. So if I want this car to take left turn, then it has to go inside the board. It has to go inside the board like this. This vector will cause the car to turn in the left direction. Okay. So now I need to pick up this vector and place it over here. This will be precision. This will be precision. Okay. I told you the trick already. Rotate omega spin in the direction of omega precision by 90 degrees. If I am rotating this in the direction of precision by 90 degrees, let us say the vector omega spin is like this. I need to rotate this in the direction of omega spin. So if I am rotating this, then the vector, transformed vector, will be pointing towards left hand side. This will be active gyroscope. This will be active gyroscope. And opposite to this will be reactive gyroscope. Opposite to this will be reactive gyroscope. I have to do simple one thing, that is point the thumb in the direction of reactive gyroscope. I can see the fingers curling like this. I can see the fingers curling in this fashion. So draw this couple like this. Pick up this couple and place it on the vehicle. Okay. Pick up this couple and place it on the vehicle. Now, if the vehicle is taking the left turn, the wheels which are visible on our side will be the outer wheels. and the wheels on the back side, will be the inner wheels. The inner wheels are going to get lifted from the ground, which means that there will be decrease in reaction on the inner wheels. I hope everybody is able to understand the reactive gyroscope, direction of reactive gyroscope. Yes? So once you are picking and placing this vector, the wheels which are present on our side, what we are seeing here are the outer wheels, and the wheels which are on the back side of this will be the inner wheels. So this vector will cause the inner wheels to get lifted. Okay? Once the inner wheels are getting lifted, the reaction force on the inner wheels will be decreased. So if this is taking left hand turn, these are inner wheels. So the reaction on the inner wheels has to be decreased. This will be P by 2 and this will be also P by 2. And outer wheels will be pressed against the ground. The reaction on the outer wheels will be increased. This will be plus P by 2 and this will be also plus P by 2. I hope everybody is clear. Similarly, when it is taking the left turn on the curved path, so the centrifugal force will try to throw this vehicle out of the path. When the centrifugal force is throwing this vehicle out of the path, you can see still the inner wheels are getting lifted and outer wheels are pressed against the ground. Outer wheels are pressed against the ground. More reaction on the outer wheels, Q by 2 and Q by 2. Okay, so you might have seen already this accident happened somewhere about 3-4 years back in the, that is what we have, the flyover which is there in high-tech city. So you can use that, you can see that video and then analyze. The vehicle will be thrown radially outward. Centrifugal force is going to throw the vehicle radially outward, out of the curved path. Okay, the vehicle will not go toward the center of the curvature. It will be thrown away from the center of curvature. So here again the inner wheels will be lifted from the ground and outer wheels will be pressed against the ground. So here again the centrifugal force is going to decrease the reaction force on the inner wheels, and similarly it is going to decrease the reaction on the outer wheels also. Okay, so these are few questions, guys, what I have discussed. So let me just check the chat box if anybody is having any questions. So we'll see that. So I guess nobody has responded in the chat box, so we'll be closing the session now. Good night everyone and all the best for your examination. you.